Imagine waking up to find the entire world flipped upside down, gravity pulling you straight out of your bed toward the ceiling. In this wild one-day experiment, architects race to rethink every beam, bolt, and brick. First challenge: foundations. Normally, we bury heavy stone deep in soil to resist downward force. Now, foundations must cling to the roof like suction cups or grappling hooks. Engineers borrow spider silk ideas, designing tension cables that wrap ceilings in a web, converting loads into anchor tension instead of downward compression. Next hurdle: walls and columns. Traditional columns work under compression, but under reverse gravity, they'd snap in tension like broken rubber bands. So we switch to tensile structures. Think fabric canopies stretched between rooftop anchors. Steel cables and carbon fiber rod form a lattice that supports floors from above. Finite element simulations confirm these tensile meshes handle the inverted loads smoothly, avoiding Euler-Buchmann catastrophe.
Windows become floating bubbles.
Glass panes hang from frames like stained glass chandelier. To keep them from drifting, architects embed magnetic strips in the frames, using repulsion fields to gently press the glass outward and hold it in place. It feels like walking through a graceful glass forest overhead. Water is next. Plumbing normally feeds taps by gravity, but inverted plumbing pumps water up and out of ceiling tanks. Engineers deploy variable speed pumps controlled by pressure sensors to avoid surges. Toilets now flush upward into overhead reservoirs. An absurd image, but perfectly manageable, with airlock valves derived from submarine hatch designs. Elevators transform into ceiling-hanging gondolas. They move on rails, suspended from the original roof joists, powered by reversible motors that switch direction in under a second. Emergency brakes lock instantly if power fails, gripping the track like a mechanical gecko. Fire escapes. They swing down as curved ladders fixed to the ceiling, creating inverted loops you climb head first. It's a thrilling new experience, like spelunking through a topsy-turvy cave system. In structural tests, researchers observe interesting phenomena. Steel under tension stretches slightly, absorbing energy and dampening building sway during wind gusts. Randomly, some tall skylights start to oscillate, like giant strings on an upside-down harp. Architects harness this as a musical instrument, embedding tuned cables to produce harmonic chimes when breezes blow. The result: a city that sings to the sky. By day's end, this gravity-reversed city teaches us fresh lessons. Structures can be both rigid and supple. Tension-based design can rival compression, and architecture becomes a dynamic performance rather than static shock. When gravity snaps back at midnight, we'll collapse our tensile webs and watch buildings settle gently back to earth. Yet those fleeting hours reveal a new frontier, designing homes that can flit, twist, and dance with the forces of nature, inspiring a future where architecture adapts to any pull-up or down.